Welcome to Session 4, Inequalities and Number Lines. Today you will solve and graph one variable inequalities. Reverse the comparison after multiplying or dividing by a negative, and interpret inequality solutions in context. Watch the structure, not just the arithmetic, because each move must preserve the meaning of the problem. The visual gives us the central idea. Treat the endpoint as a boundary. A strict sign excludes it, so the circle is open. An inclusive sign includes it, so the circle is filled. The shaded region represents infinitely many values, not just the endpoint marked on the number line. Use this first move. Solve as if the comparison sign were an equals sign. Then, reverse the sign only when multiplying or dividing both sides by a negative. Worked example, inclusive boundary. Solve 5x2 is less than or equal to 18. Step 1. Add 2. 5x is less than or equal to 20. Step 2. Divide by positive 5, so the sign stays. X is less than or equal to 4. Step 3. Graph a closed circle at 4 and shade left. The final answer is x is less than or equal to 4. Check that it satisfies the original conditions and carries the correct units. Now it is your turn. Solve minus 4x plus 5 is greater than or equal to 17. Pause, write each algebra step, and use the next 6 seconds to finish your solution. Here is the modeled solution. The answer is x is less than or equal to minus 3. After subtracting 5, division by minus 4 reverses the sign. Verify it against the exact wording before moving on. Session 4 recap. Solve as if the comparison sign were an equal sign. Next, reverse the sign only when multiplying or dividing both sides by a negative. Then, choose an open or closed endpoint from the original comparison. Finally, test one shaded value in the original inequality. A complete solution shows the reasoning, checks the result, and states what the answer means.